Today we are thrilled to host Jeff, a trailblazer in AI ML system engineering, open source innovation, and bridging the cutting edge research with real world impact. Jeff's career spans foundational projects like leading PyTorch at Meta, where he drove acquisitions of papers with code, incubated breakthroughs like Llama and Mistral through Fair Accel, and he is author of Machine Learning Systems Designed That Scale, exploring deep learning for language essential reads for engineering tracking scalability, language, AI, and the messy reality of deploying the models. And beyond the big Jeff has saved the startups in conversational AI, neuromotor interfaces for AR, and cloud machine learning infrastructure. And he is now pioneering multimodal and image research while advising the accelerators and founders. And yeah, let's dive into his journey, lessons, and his future vision for the future of humanity that's there. So I will start with your experience at PyTorch leadership. So what inspired the creation of the PyTorch, and how did you differ it from existing frameworks at the time?
Sure. So let's see. To ground folks on what role I play in the PyTorch story is that there are many folks involved in the story of where does PyTorch come from. When I got involved was when the creators of PyTorch, who were really all research engineers, had built enough excitement around the project that the company was really starting to invest in it. And so I came in as the first professional manager to help scale up the organization. So Sumit Shintala, one of the creators of the organization of PyTorch as a technology, passed off like his management responsibilities to me, and then took over like exclusively focusing on technology. And so what we really kind of partnered on in that phase of building PyTorch as a project is it was already a really interesting research technology, but it needed to reach a lot more people in a lot of different ways. And so at the specific point of like say PyTorch 1.0, which was concurrent with roughly TensorFlow 2.0, a big challenge that we had to overcome was some researchers really liked PyTorch for its flexibility, for its ease of use, but there wasn't much of a production deployment story. There wasn't really an on-device story. And then a lot of the things that people broadly needed to do with a deep learning framework weren't yet possible in PyTorch, and were not necessarily aligned with the goals of the FAIR research organization, Facebook AI Research at that point, to really like forward fundamental AI research. And so a big part of that is building the ecosystem. So really building close relationships with Amazon, Microsoft, Google, Intel, NVIDIA, so on and so forth, as well as like every academic open source contributor who really wanted to make something better. And that includes folks like, interning in the group at one point in time was William Falcon, who created Lightning, which is now a standalone company. And so like folks like that who want to bring substantial value, Hugging Face folks who were at the time building transformers, and we had to collaborate on building out our reference implementations of attention and having the community adopt PyTorch-centric implementations. There's just all of these different stories of what different people need. That's a big part of like the space that I worked within for a long time. Is just helping people come together and collaborate on a big open and ever expanding tent. And so like our key concern was go from this thing that like some researchers really love to the thing that just touches more and more people and solves things across the full life cycle, including when you're doing a vision model deployed on a mobile device, and you're writing in Kotlin, and so you need a Java API to call into a frozen CB model, or you're deploying to cloud-based inference, and you need to be able to get really efficient model management and everything. All those different places you could be within real-world application machine learning. They really are the work of many, many companies, organizations, independent development groups, and you just try to foster productive collaboration in the open. Thankfully, PyTorch got to stay a completely open source technology from day zero. there was never really a closed source version of this. This was always something that the door was open for everyone to contribute, and that's continued to be how the project has grown, including in its current stage. It's now even less Facebook controlled and more just fully organized by open source contributors around the industry from multiple organizations.
That's really awesome. So how did you acquiring papers with code align with your vision for PyTorch's role in the AI community?
Yeah, so Papers with Code was playing a really interesting role in the ecosystem at the time we acquired them. And so one of the key challenges we found in the early stages of building up a sufficient deep learning framework ecosystem was that the reuse of other people's work was really just very challenging, and understanding where those implementations were, which ones to use, and how they related was really, really hard. And so I think Robin and Ross and the team at Papers with Code really did a great job of taking a very research-centric view of that and creating a home where you could kind of bring together those insights of where how are the implementations being used, and that allows you to like reason more about lots of different things. And so this included like growth of things like understanding data sets and benchmarks and so forth like that I think remain like to be critical questions for the community. Some of those I think are now have additional competing solutions from other people. I would say Hugging Face has grown a ton in this space that Papers with Code was originally operating in. But one of the interesting things that the Papers with Code story evolved into is a somewhat controversial research project called Galactica. And that work was an attempt to really build a foundation model for scientific research. It's one of those really powerful implications of really having models which have deep domain-specific expertise. If you can have an AI model that understands AI research from the level of both source code and from the text of papers themselves, then there's incredible things that could be possible with that. The challenge, of course, is really achieving a useful level of performance that doesn't set the wrong expectation for users. And so in that case of that particular project, it was really impressive research that got pulled down almost immediately in response to a little bit of public press blowback on really what's just an error rate from hallucinations. And I think we've continued to see this problem in the years afterwards in both general purpose and in domain-specific LLMs. For example, there have been cases filed in federal court that cite precedent from cases that never existed because some legal tool chain was calling into an LLM, which hallucinated prior legal precedent. And so we're seeing this across the field, is that we are moving forward in the presence of accuracy rates that are lower than 100%. It's one of the challenges of bringing to bear AI technology in real problems. AI never comes with this guarantee of deterministic, perfect accuracy, but we get to make choices as societies about utility. When is it good enough to be useful and impactful? And so Papers with Code, I think, did some really great pathfinding work, and now that team is largely on to building new things, which most of what they're building is secret these days. That whole team is past Facebook and Meta and back into startup land, and they may invent something new that they can tell the world about, but not today.
That's a really amazing thing about the science and innovation, right? Like things are at a certain level that new things are going to come. Like just like reinforcement learning is at certain level right now that we cannot think what is going to happen. So what do you think about reinforcement learning? Do you think models can be able to learn by themselves, like reading the papers and understanding and doing what we call as research by themselves?
Yeah, so I mean, I think there's a strong intersection when we talk about like these sorts of applications, reinforcement learning, with just agentic modeling of domain problems in general. The best experience I have in getting a sense of how some of this will play out, because I'm not a domain-specific expert in reinforcement learning, comes from working with Noam Brown on superhuman diplomacy and some of his related work in multi-agent reinforcement learning in games. So for those of you who may not know GNOME, GNOME first got a little bit of press for being the first person to achieve superhuman poker performance. And that was his PhD thesis. And then he came to work with us at FAIR for a while, where he worked on superhuman performance in a number of different games, and then eventually leading to superhuman performance in Diplomacy, which is a socially oriented board game about a land war in Europe, where people coordinate and build alliances purely in text and then take game actions. And so there's this really interesting intersection of language modeling, challenges of can you convince someone that you are a person, you make trustworthy promises, and then have that be aligned to your actions. Can you take superior gameplay actions? And so as an interesting data point, I think that's a good one in that we see the best success of reinforcement learning within constrained environments, artificial environments of some sort. Games are a great test bed for RL research. That's always been where we've seen the most impressive results in RL. Things like the StarCraft results and things like that are great because games are effectively infinite sources of synthetic training data. And I think there's a ton of further progress to be made in that space. I'd say that the biggest people who I think of pursuing this now within the large tent of AI researchers are probably the robotics folks working within the sim to real paradigms, where skills are developed within simulated environments and then transferred to real robotic environments for validation. I think that's where we're seeing that prove out. That said, I would say, kind of leaning on the perspective of my ex-colleague, Jan LeCun, Turing Award winner, inventor CNNs, etc. One of his consistent metaphors about RL involves a fancy frosted cake with a cherry on top. And his point with respect to reinforcement learning is that it is a portion of what we are doing within AI, and it plays a critical role, but it is in and of itself not the thing in and of itself. It's not the way to solve everything. It's simply one tool, and I think you see that in the way that modern like foundation scale LLMs function. This is what Noam Brown is now working on, multi-agent reinforcement learning at OpenAI. And so where human preference alignment within LLMs has proven to be a highly successful application of reinforcement learning, but it's not necessarily how we're modeling a huge range of other problems. It's just simply a way to achieve some sorts of optimization alignment type goals. I think I am broadly optimistic about the use of synthetic data, simulated environments generally for a lot of domains, and the applicability of RL, I would say, is highly constrained to the growth of having those sorts of environments to work within. Absent a constrained game-like environment, there seems to be very little application of RL outside of those sorts of spaces. It's very hard without given the data hungriness of RL as a methodology. You need a sort of infinite data source like a video game environment to really be able to get the maximum benefit. So I think those questions are tightly intertwined. The growth of simulated.
So the hungriness for data for the reinforcement learning algorithms. One thing comes into my mind is if we create some kind of simulation or emulation of quantum world or quantum computing or all things go around those parts of the science, then maybe we can have a lot of data which we can feed to the RL algorithms. What do you think about that?
So I do think there's probably application of RL-like methodologies to deep scientific domains that can be made data-rich, including through simulated environments. My understanding is that our comprehension of some of the problems of unique interest to the quantum computing community is that we don't have the ability to build such a simulator or anything close. I think where you can see perhaps closer approach of the ability to bring to bear RL for simulation purposes is a lot of the progress that's been made in the molecular biology domain. And so that's, there's some famous groups out of DeepMind, our team back at FAIR that built evolutionary scale. so the ESMFold line of models that spawned off two distinct companies now, Evolutionary, Scale, and Chi Discovery. It's clear that there's quite a lot that you can learn in areas where we have a really good understanding of the underlying mechanics, but there are still substantial challenges in reasoning about the interaction of a total like set of components in some sorts. And so like a big part of why molecular biology is hard is that we can sort of understand the interaction of like one molecule with another molecule in a very like, this binds to that sort of way, like where it's Legos. But the building blocks of life are so many different things interacting in such a complex space that it can be hard to search through all of that and understand all the implications. And so there's been substantial progress from a number of groups in being able to build foundation models, make predictions that are validatable. I think this is another thing where like, if you think about like what constrains progress, a good mental model is verifiers. So where do we have the ability to verify that any of our predictions are right, and at what cost and scale? And so, for example, you see tremendous improvements within theorem proving and mathematical domains where you have extremely high quality deterministic verifiers. You have pretty good progress in the molecular biology domain where there's already been this huge increase over the past 20, 30 years or something in the amount of high throughput genomic screening technologies of various sorts. We have high throughput genome sequencing. We have all sorts of abilities to perform diagnostic tests of higher order phenotypic characteristics. And so like the biology lab's already been turned into this like high throughput data acquisition machine. And so we have good verifiers in that space as well. And so to me, I am not an expert at all in anything quantum, but my understanding is that we largely don't have that, and that's actually kind of a big part of the problem within quantum, is that there's very little reproducibility or robustness in our ability to understand just at a sense level capture of data. And so I think there's probably going to be things that move faster in terms of their ability to exploit those opportunities. Things that are closer to like chemistry and things like that, like material sciences is definitely seeing ability to move forward through exploration of alternative materials through the use of reasonable verifier workloads and things like that, ways in which you can automate the testing and solve your data sufficiency problems.
That's awesome. So, as PyTorch has become Meta's AI backbone now, how did you ensure it remained neutral tool for broader community?
I think there was a clear understanding that grew from, I would say, a minority of people into a majority of people about the role in which truly open technologies would play within the growth of AI developer tooling infrastructure generally. And so you can think of, it's like Jan LeCun, who built FAIR over a decade ago, coming from academia, expecting everything to be open data, open code, open papers by default, no secrets. That's how academia advances. We all stand on the shoulders of giants and recombine each other's work. That philosophy was the foundation of FAIR for a very long time. Inside like large tech organizations, I think you've seen a big spectrum from classic old Microsoft, everything was closed source and open source was treated as a cancer, to very open source friendly organizations, including Microsoft having completely changed their story to being very positive about a number of open source technologies, from PyTorch. They adopted the Onyx technology, which we developed at PyTorch, including developing their own Onyx style model server. And all the way down to playing a more positive role with things like Linux, VS Code, etc. Specifically within like that story of how that changes is that I think people see the business case of those things as they start to really drive adoption. The first thing that matters for like giving people the ability to invest in doing an open source project that was frankly quite involved and expensive, like PyTorch. Is really being able to point to the benefits. Some of the first things that land that are really obvious is that Facebook originally had a different production deep learning framework technology called Cafe2, developed by Yanqing Jia and others. and it was only used at Facebook, basically speaking. It was open, but it did not have a viable community around it. It was part of a large community of what I would describe as static graph construction forms of deep learning frameworks, of which TensorFlow became the defining example. And so there's a huge number of frameworks that look like that. No one came in the door really knowing Cafe2 from their academic experience. We saw no real contributions to the core framework or to any domain-specific libraries coming from outside the community. Whereas on the PyTorch side of things, it was just developed for some researchers to do their research. But the fact that everyone else used it for their research became immediately useful because we could validate their research. We could bring in the community's libraries and recombine and test. It gave us a surface area to be able to provide out things to people that we wanted them to evaluate, so we could define a domain-specific library like Torch Vision. We could define a benchmark data set. We could take in those sorts of contributions from other people, and that immediately starts to deliver impact on what gets accomplished. And then you get to all of those other second-order things once you see people like infrastructure providers getting on board. So in the current state of things, that there are teams at every major infrastructure provider who are responsible for, at NVIDIA, making faster and faster kernels, which are aware of what PyTorch needs. At Google on the XLA team, understanding how properly to translate PyTorch programs down to XLA execution for acceleration on Google Cloud TPUs. That all of those things are just benefits to the total community, and that in the grand scheme of things, that the bigger sum of those is just really substantial. And I think that the nicety is in Facebook's particular case, because they were not an infrastructure provider, because they didn't sell servers to people, because they, whether as a cloud or as a hardware producer, there's just really no incentive to keeping something like a deep learning framework inside the building. And so, it really gave us some space to be able to make the argument for these sort of ecosystem effects are really, really beneficial to the company in terms of everything they do for developer efficiency, for reuse of other people's work, for the ability to get the best performance for our workloads on the next generation of the NVIDIA devices, because the NVIDIA developers were testing all of their workloads on PyTorch code. It just puts you in a nice position to be able to really be part of a healthy feedback loop in every part of your work. And I think that's now the norm. I think that's why there's substantially less interest than there was, say, 7-8 years ago in the idea of competition in the deep learning framework space. It's just it's so much better that there's very little competition these days. PyTorch is the vast majority of all deep learning code written these days. It's not the only framework that people author new things in, but even then, I'd say the tools for reuse across frameworks are substantially more mature than they were back in the sort of early days of 7-8 years ago.
Completely. Standing on the shoulders of the giant is really awesome way to learn and grow and innovate new things. And with the Pair, Accel and projects, what was Pair Accel's mission, and how did the projects like Llama and Mistral align with it?
Sure. So a little bit of clarification there, because I think there was some slight misstatement at the beginning there. FAIR was Facebook's AI research group, fundamental AI research, always organized around open data, open code, open papers, and really like self-directed research on large, important fundamental topics in a model that's been copied by a lot of other organizations. For that matter, even organizations that previously did entirely closed-source work. There was a point in time which we realized we really needed to organize ourselves around providing deeper resources for bigger science. And so I think one of the evolutions in AI within the past, let's call it 5 years or something, is that there became classes of research that were really only possible to do once you could have tens of people together and have pretty substantial budgets, somewhat for data, somewhat for infrastructure, but they involve more business sign-off. And so we built some structure around that. That was a division of FAIR that we called Accel. The part that I was responsible for pulling together at the time was was a collection of projects that we eventually ended up calling Math and Science. And so these were chiefly projects that were really kind of fundamental and non-domain aligned research. And so they weren't solving a problem that was in Facebook's products. They were really just sort of deeply interesting for the research they uncovered. And so some of those projects were purely, for the purpose of fundamental work. And so that's things like the superhuman diplomacy, led by Noam Brown and Adam Clarer. Some of those works were focused on biology. So that's the ESMFold team. People like Alex Reeves and Tom Sarkood, Josh as well. And then some of that work was focused on theorem proving. And so the theorem proving work got published specifically as work on how to do cross-theorem proving framework reasoning about how to advance learning from different sorts of theorem provers and compose that up into superior understanding of mathematical knowledge. The group that did that work went on to then create Llama as a separate distinct offshoot from some of the investigations they did, and then left Facebook to found Mystery. And so, just concretely, those are all contributions by people like Guillaume Lampel and his team of researchers and things like that. I think what I was trying to reference in some of our notes in previous discussion is in organizing people to do deep, ambitious research, people found even bigger targets than what they wrote down to start with. And so solving, mathematical theorem proving was already incredibly ambitious, but then it led to doing even more work. And so, a lot of this is about it's just an incredibly rewarding and really lucky time to be working within the field of BI research, in that there can be tremendous returns in asking really interesting questions, and they can lead you to places even more promising than where you start. And I think that's been a big part of the history of some of the folks who, like me, were at FAIR and then went on to other places and did other things, is that there's so much to be done in AI research right now, and you can really get a hold of some really juicy and interesting questions. And you don't sort of have to kind of just stay in the sort of incremental paper, little thing. There's some big, wildly exciting jumps forward we're making across the field, and I think that's why you see so many people grabbing new missions and trying to really see if they can find a way to create the future.
All right, yeah. It is completely really amazing time to be alive right now, because a lot of new things are happening, a lot of new research is coming up. So how do you balance the tension between open sourcing the foundational models like Llama and the Meta's proprietary interest?
Yeah, I think organizations have different incentives based on what their core business model is. And so an interesting thing that I've seen these days is that language models are commonly open source. There's really a minimal amount of closed source language models used by anyone, maybe the Gemini hosted version or something like that. But even substantial portions of that are in the open source. Vision models are pretty open source at this point. And so, there's GPT-4o Vision is not open source, but there are many comparable ones like Quinn and Intern DL and Llama Vision, et cetera. But there's some categories of stuff where people are really, really not open sourcing their work, and I think that's an interesting one to reason about what are their incentives. And so I'd say there are some open source image generation models, but there's a huge divide between the academic and the commercial products there in terms of the evidenced image quality and presumed investment on training data and training infrastructure. The same is even more extremely true of video models, where there's a huge divide between what's available in the open and what's available in closed source. And even then, definitions of what is open. And so along this spectrum, when we say open, some things are open weights. A smaller portion of any of these classes of models are actually truly open source to the level of being able to reproduce it, inclusive of their data. And most of them are, I would say, like lagging academic open benchmarks. They're the best in the world for any of these product categories. Is not fully open at the level of open source. It's usually at best open at the level of open weights, which is good for access, but also frequently when we say open weights, it often comes with license restrictions as well, that can constrain what sorts of innovation are possible there. And so when you think about like how can the advances be recombined to take the next step, you get in this really interesting place there of as a researcher, you would expect to be able to implement any given loss function that was in any past paper and then just use it directly. But in some of these areas, a lot of the results are constrained by substantial data set sizes and huge compute investments. There are ways that you can work on efficiency and superior compute investments, and even data efficiency at a methodological level. But there is a sort of difference in what proves to be addressable in what I would call academic and nonprofit type research versus industrial research. That shows up in some of these things. You can have the best methods in the world come out of an academic paper, but then you try to test them all, and it doesn't really look like the world's best model, because what you're mentally set at a benchmark of a commercial product that had tens to hundreds of millions of dollars more poured into it, that show up in ways that are not about methodological differences, but are rather about data and compute.
Completely. So could democratizing, like making models open source, like Llama, make barriers lower for malicious actor? And if that's the case, how we mitigate that?
I don't really think there's much danger in open sourcing for malicious actors. I mean, a malicious actor can afford to have an OpenAI subscription. So what do they care if the model's open source? They can feed it bad stuff. In some cases, so like for example, jailbreaking most safety concerns is really just, it's pretty straightforward for any sort of adversarial actors these days at an LLM level. Safety is a pretty thin concept, I would say, in a language model level. And for that matter, like the methodology of reproducing any models is pretty straightforward. So like depending on how you interpret the latest like DeepSeek R1 results, one conclusion you can draw from that is that you can do substantial, you can get substantially close to the state of the art through pure synthetic data augmentation and distillation, meaning you do not need direct access to the implementation, training code, or weights if you have access to the instances. And people have been experimenting on this in a number of domains. There's huge collections, for example, of stable diffusion and mid-journey images used for academic research. And so you don't have access, for example, to mid-journey's weights or its implementations. It's a pure commercial product. But you can access tens of millions of their images. And so at what point can you reverse engineer that from those sorts of things? So I tend to think that safety conversations and open source they're not in conflict.
Right.
I think that if you have fluency in AI research these days, you can figure out how people are building any one of these models, and adversarial actors can't be prevented by somehow not having access to the same Gen AI capabilities we all have access to.
Right. So going over to the neuromotor, and what's the core idea behind the neuromotor interfaces, and how do they enhance augmented reality experiences?
Yeah, so I'll talk about this one a little bit in terms of historical terms, but then I'll have to be careful to not sort of project into the future on things that I can't speak about. This line of technology was developed as a startup here in New York called Control Labs. And then about 5 years ago, it was acquired by Facebook. And then within the past few years, you've seen Zuck and Michael Abrash show up at Connect and give people a preview of where the research is going. I think some of that's also resulted in a scientific publication, as well as a couple of white paper type reports. And what they talk about are generally a surface EMG technology that sits at the wrist, detects neuromotor impulses, and so thus can be used as a control scheme for an augmented reality interface, and so that you can use that to, in much the same fashion you use a keyboard and mouse to interact with a desktop computer. A face-based augmented reality computing platform needs some sort of interaction modality. And so if you look at current gen products in the market, Ray-Ban Metas today use voice control primarily. And then in the VR space, there is a form of hand tracking. It's available on things like the Quest line, things like that. And so as you get into AR, you need to have those same concerns of like, how is it that I can interact with an AR device when I'm in a mobile personal computing context. And so the solution proposed by this line of work is to detect neuromotor intent at the wrist, understand how just someone's moving their hands, develop up a control scheme, and use that as something that is really powerful and hopefully very easy to learn. Very easy to use and robust to a lot of situations. I think that's the dream of that whole line of work. Really beginning at the level of the Control Lab startup. I think you can see their vision laid out for years in their career as a startup.
Right. So what's difficult? Engineering low latency signal processing, or ensuring user to trust in neural data privacy?
I can speak about why is this technology hard to develop at all? Is in general this is not a trivial thing to be able to robustly understand the human nervous system in such a way that you can detect concretely the electrical impulses that correspond to a given intent to swipe left or something like that. That was an unsolved problem before the Control Labs team began work on that. And so I think that in itself is the absolute hardest thing. And then there's plenty of other reasons why you could project out why else might it be hard. Well, it's maybe you and I aren't exactly the same. Maybe you and I aren't the same size. Maybe our anatomy is not the same. Maybe the humidity in this room isn't the same. The environments we're in certain ways, the motions we make. Maybe we misunderstood the training things that make a slightly different motion. There's all sorts of really challenging problems about any time that you try to solve any form of understanding human intent and then mapping that to discrete computer comprehensible interface technologies. We forget how hard it was to ever get speech recognition to work. Being able to have a transcript of a call like this was once a sci-fi fantasy. The idea that you could talk to a computer and get it to do the things you want it to do, like turn on the lights, play my favorite music, was literally in science fiction when I was a child, but has become a completely solved and everyday and prosaic technology. And so that and there's just enormous heterogeneity in how every single person speaks. Even in a monolingual context, it's an extraordinarily hard problem. And the same is true of any interface technology that seeks to go from what are really the fully complex actions of a human into a sort of computer comprehensible space. And so we've made huge advances in speech recognition. We've made them in language understanding. We've made them in computer vision. The ability to know that I'm holding up 2 fingers, now I'm holding up 3. Things like that are completely solved. It's really hard if you actually go below the skin level and try to get into the nervous system and understand exactly what's going on. It's a deep, hard problem, particularly if your goal is consumer technology. Consumers are extraordinarily unforgiving of interface technologies that aren't good enough. If you read PC gaming forums on Reddit or something like that about latency of this mouse for a first-person shooter or something like that, people are really care about how their interface technologies work for interactions with computers. It's just it's an area that people I think have a really good understanding of what they want things to work like. When I press a key, I want it to be absolutely instantaneous. When I move the mouse, it needs to be absolutely instantaneous, and it needs to be accurate. And the idea that I think because we have such highly reliable interface technologies, this is some of the still remaining challenges of things like speech use cases. All of the automatic speech recognition is effectively about as solved as it's ever going to be. But it's still imperfect, and there are still people who find it unacceptable for their use case because for example, they're speaking a language where their first name is not common, and thus their first name is never accurately transcribed by the ASR. And that problem will probably is very, it ends up being an application level issue, or categories where there's highly domain specific terminology being used, or the way in which you want to use this speech recognition technology. I know folks who were trying to deploy ASR in a farming environment next to several 100-pound cows because they're doing a physical inspection of livestock, and so they can't actually have their hands tied up. They can't be at risk of getting trampled by a giant bull because they're looking down and writing down notes. But that is a loud environment. And that's just like inherently challenging to get highly reliable records from something like that. And so interface technologies are just gonna be hard, and I think and consumers are gonna be incredibly demanding. And I think that's going to progress for every generation of human-computer interface that we try to define. Like at the wrist is not where it stops. There are certainly people out there in the world who are, cracking monkey skulls and sticking chips inside, and people have all sorts of ideas about how deep inside, understanding the neuromotor system we need to get to be able to achieve truly seamless human-computer interfaces. It's an ongoing field, and there'll continue to be people working away at the hard versions of this problem.
Right. So, yeah, I think this technology might create something like users are depending on this technology for day-to-day functions, just like we see in the science fiction. So the average average person, at least in huge portions of the world today, is like the United States, are just spending a lot of their day interacting with the computer, whether that's a laptop, an iPad, a phone. They are spending a huge portion of their time interacting with different sorts of computing technologies, and the interface technology that determines that plays a role in what becomes possible and in what ways technology gets used. And it's also deeply intertwined with what's the future of the integration of AI technologies in everyday social life. The ability to, if I tap my ear right now and I've got a voice assistant in my ear, I now have access to the entirety of human information. There's no question you can ask me that I can't know the answer to. Does that start to change how we solve different problems, how we organize work, how we socialize? I think that the sort of story of interfaces and AI are very, very close together in terms of how they're going to drive the surprising and truly new ways in which we use technology in the future. That will be really fascinating thing to see. So, going forward with your another startup, IPsoft. So, what's the biggest technical challenge in building AI for customer service versus other domains?
Yeah, so let's see. These days, I think most people know IPsoft by the name of the product that I ran R&D for, which is called Amelia. At the time, it had multiple products and has since been acquired, I think, by SoundHound. Going back in time, what it was really Amelia was working on was a general purpose conversational agent targeted at important industry conversational workloads. And so what that tends to mean is customer service and things that look like customer service, so like IT help desk and things like that, where there's a sort of constrained knowledge base. There are things we know we do. We sell these products, they get shipped in the mail, et cetera, things like that. And there's a large flow of conversations, and that this is viewed as something of a cost center to optimize. And so, oftentimes, companies are really looking for efficiencies out of minimizing how much spend they do on returns and customer service. Now, and this is an area that people have been working on for generations of technology. It's started to get really good within the past couple of years. I think one of the biggest things that we ended up working on that was really challenging was we wanted to maintain extraordinarily high accuracy, but we also had a lot of commercial movement across geographies and languages. And so, for a while there, I would say that the field of NLP, of any sort of language-centric AI research, was not progressing at an equal rate by language, meaning that there were results that you could achieve in English that you could not necessarily replicate to every language for which there was a customer. And so we saw this a lot within highly multilingual European customers. But we also found this really challenging even within like, sort of dedicated, big bad, like deep dive sort of projects that interfaced with Japanese customers. So it was a clear market success for us. We had folks on the team with Japanese language expertise. We had close partnerships with very large Japanese customers that made it worth it for us to go deep. But the real challenge there is when you're doing a lot of this work that spans so many languages, if it takes 30, 50 people to make a total product come together, and you're trying to make it general purpose for people around the world, by definition, the team I have sitting in New York doesn't speak every language. So if we have 3 people that speak Japanese, that doesn't mean we have 50. That means that there's all sorts of issues that can pop up in understanding how good you are and what ways to make things better, develop product intuition. And so I think that the real challenges of being at a high enough accuracy for real world commercial utility, and being able to do that multilingually, and know that you're doing that right and really having that confidence, proved to be really, really challenging. A lot of those things have been made better within more recent years by broader advances in the field. But I do think that verifier's problem still is really, really true. Is that like, if the person sitting at the keyboard at every step can't read the language on the screen, can't comprehend if that's correct or not, you've accumulated basically a risk factor that needs to be addressed somewhere within your total product development life cycle. And so I think that the confidence level for which we should have of how generally capable is an AI across all languages, if you look into the details, it's the vast majority of AI progress is being made in English, Chinese, and every other language in the world. By almost any benchmark for any category of application is always a little bit worse than English or Chinese. And that can have real world implications depending on what sort of use cases you're trying to solve. Because there's, see if you're at the popularity of French, maybe that doesn't matter. But if you're at the 35th most spoken language in Africa, it may have radical implications around your ability to deploy a customer service automation to, an African mobile phone company's customer service operations or something like that. It may just be a completely infeasible technical goal. It really, really matters, like some of the specifics of these things, particularly if you want to deploy them to consequential, commercially important sort of situations. We don't have an equal world in the development of AI technologies across languages, across cultures. That continues to be an open area of research, both just to know where we stand and then to make actions to close those gaps. Both of those remain hard areas.
Do you think AI agents should disclose their non-human to users, or does that undermine their effectiveness?
I don't really see a reason where I as a technologist should have to misrepresent the outcome of the program as anything other than it is. That doesn't really strike me as a well-formed task. So if you have to lie to get the job done, I'm not sure that you've defined the job right. And so in general, I think if you have humans interacting with technology, I think it's vastly more ethical to just disclose that by default. Obviously, there's a huge range of applications today where people are not doing so. And I think that creates a number of challenges. I'm personally not interested in working on anything where I think there's a distinct difference between surfacing up a conversational, human-like interface for the purpose of a user experience to make it easier for you to solve your job by just explaining your problem. I think that is a empathetic user experience that you can design for many sorts of products. But that is completely different than masquerading as if you're a specific human. I think that's a completely different product positioning. So I don't see why anyone would be doing that. But I think there are tons of adversarial use cases around web, and I think they're growing. From my knowledge of folks working in integrity, trust, and safety teams around the industry, this problem just keeps getting worse and worse because the ability to generate ever more lifelike human text, for example, And increasingly within images and videos, it just keeps getting closer and closer to being imperceptible by the average human. And so it creates really large challenges for anyone who's trying to mediate online discourse or engage in, human-to-human transactions and things like that. There's a lot of adversarial use cases which look really promising to bad actors these days.
Right. Moving forward to your John Doe vocal agent startup. So, what inspired you to found your vocal agent startup, and what was the gap were you addressing?
Sure. So John Dunn was at an earlier point in technology. I co-founded the startup with another colleague. It was based on the insight that we already had conversational agents that could perform tasks, and that there were kind of two big open interfaces. And so my co-founder and I, at the time, were working within an organization called X.AI, the original one, that scheduled meetings over email using a conversational agent. So email is one of those big open interfaces. The other open interface we spent our time thinking about that caused us to found John Dunn was the phone. Is that there's a large number of interactions where you need to go out and acquire some piece of information to accomplish a task, and it's a person who's only reachable by a telephone. The information only exists out there, and that itself is an irritation and out of sync with user interaction modalities. That generally speaking, people don't want to make outbound phone calls, in order people want to receive them these days. And so we were inspired just because it seemed buildable to be able to make such a thing, to make phone calls and solve tasks. And so that was really the impetus of that one. That one was a fairly short-lived company. I would say we were a little bit too early in the technology cycle to really be able to achieve everything we wanted to do, but did generate some excitement, got raised investment from a great firm, BetaWorks, who continues to invest in a lot of really exciting AI companies. And so, having worked with them a bit, I think they've been good about being optimistic and early and willing to lean into those things that are ambitious and maybe a bit before their time. And so they're, for example, one of their successful investments out of that whole crop of things is Hugging Face, who they invested in long before they had sort of the business model they've landed on. So I think that's often the case. You try to live at the edge of what's possible, is that you're going to frequently risk developing something that's too early. That's you're trying to do it the first time, and maybe the customer's not ready yet, or maybe the technology's not ready yet. I like that space because I think you learn stuff, and then you get to go out there and do things other people haven't done. I think I think most of the fun of that experience was just legitimately like testing our intuitions against the real world. Sort of unleashing a vocal agent on telephone-driven tasks that we could discover and seeing what we could accomplish successfully.
I really admire your mindset of going there and deploying some idea which you think might make you learn a lot of new stuff, and you're going out there implementing that, making it work, and still you coming from the background of just the corporate person who was just managing the teams of big companies. So normally people try to train in one setting or the another, and meeting someone who did both is really amazing. So going over to the XAI meeting scheduler thing, what's unique about the deploying machine learning in scheduling tools versus other productivity apps?
Yeah. So there's this was a really promising early target of conversational agents for a couple of reasons. One of them I've already mentioned, which is that email is a remaining open, widely deployed surface area for deploying a product. There's not that many. The open web is shrinking, and a lot of places in which you might want to deploy an application experience are effectively platforms controlled by other people. No one controls email. You can just start sending emails tomorrow. So it's a really promising way to build infrastructure that serves real world, commercially useful enterprise use cases that you can just start building it. So the company was founded by Dennis Mortensen, Alex Poon, Matt Casey, and Marcus Muniz-Manis. And those folks really were looking initially at just that problem of a lot of professional work involves setting up time to meet. You and I set up time to meet on this call. That negotiation involves a couple of different variables. People can get it right and wrong different ways. People change their minds. Something else happens on the calendar. Things have to get shuffled around, and sometimes it's overhead. Because if you and I have said, "Oh yeah, we should find a time to meet," we don't really care how we get to that. We just want to get to the right answer. But it's our time. Our time is valuable. It's our most valuable resource, and so we're not really willing to suffer errors either. Like I don't want to give you an 8 a.m. because I want to still be asleep. The same thing as like I don't want it to be in the middle of my lunch break, or I don't want to be double booked and have to cancel someone else. And so there's a bunch of like important constraints there that are computable and knowable with deterministic reasoning. But the best user experience for someone for doing this is just to have a human executive assistant, an admin, and the vast majority of people can't afford something like that. To have a whole human solve that problem for you is extraordinarily expensive. Some people still do. The vast majority of people can't afford so. And so, is there a place for AI to step in and do good enough at getting us the time, getting us the location, the method, not disrupting our calendar, understanding how we want meetings scheduled and so forth, and just doing that without requiring me as a user to learn anything, just CCing the conversational agent, have the agent take over. It's a really, really promising product proposition. For a while, we grew pretty substantially. The startup was based here in New York, down by Wall Street. Ton of excitement, raised several rounds of funding. And one of the challenges there was it was a little bit too early. It was just barely too early, but it was a little bit too early. And so one of the really difficult parts of that problem space is users are extremely intolerant of error. And it's very, very hard to prevent error. And so at the point in which we were building this product, 8 to 10 years ago, something like that, the technology was not as general purpose in terms of its language understanding, not as high accuracy, and then error rate shows up from that. So we did an extraordinary amount of data labeling and domain modeling and building up highly sophisticated classifiers of specific sorts of time and place and intent recognition of various sorts. And so that company eventually was sold to a company called Bizzabo later in its life cycle. And really was just a little bit off from kind of timing the adoption of deep learning technology that would have allowed for the sort of deeper and more efficient solution to the problem. And the interesting addendum to this story is people have seen that, realized that, oh shoot, they were just too early. They were completely right about the product. They were just too early. And so there are a number of companies building precisely the same thing over again today. Some examples I'm aware of are Howie and Eve. Both of those are I think, sub 1 year old startups trying to build meeting scheduling assistants using email as a primary interface. And we'll see if they solve it this time. It certainly looks like it's a much more tractable problem. But I can tell you, even with better technology, say you get from this sort of success rate to this sort of success rate, if the difference between here and 100% is big enough, our customers will still cancel.
Completely.
Yeah. Right. All they have to do is double book you once, put you in get the time wrong, give you a 4 a.m. meeting, any of those, any sort of error, people will fire their robot executive assistant like that. As they should, because their time is valuable. And so it's an interesting problem space to watch.
Yeah, that's really awesome. So what's your thought process? So when you go and think about here's one idea I got right now, and let's start a company through that idea. So how you decide which idea to pick and which to not?
Yeah, I mean, I think when I was younger, I'd probably say that I kind of proceed with enthusiasm, and it depends a lot on whether or not you're. There are ideas you can have where you're building technology for technologists, And so a lot of like my open source and writing and speaking work are of that flavor. And so, for example, like when I wrote the book Machine Learning Systems, every single chapter in that book I also presented originally as a talk at a meetup or an invited conference. Every illustration was on slides before it was in the book. And so I got a chance to road test those things. That book was actually requested because I wrote a viral blog post about dog poop. And then a book publisher reached out and said, we want to turn your dog poop article into a book. And so like getting that sort of validation for the technical community can be really, really accurate. You can just know what people like in software because software people know how to talk to software people. You put up a post, it showed up on the front page of Hacker News. People probably liked what you had to say. You should do more things like that. And so I would say, like, I think I mentioned him before, William Falcon with Lightning, great example of that. Pretty obvious, building an open source, people want more of it, go for it. Another ex-colleague of mine, Dow Aquila, who wrote Retrieval Augmented Generation, people really, really responded to that methodology. And so it was really obvious that, if he wanted to go out there and build a company around that, every investor in Silicon Valley would want to be a part of that. So that's where contextual AI comes from. Having recognized that was a really commercially relevant idea within his research. When you're trying to do things that's AI for other people, though, for people who are not technologists, then I think it gets much harder. And I'm spending time in this space these days of just trying to understand what is that intersection of Gen AI and commercial utility for real companies that are maybe not AI companies. And it's a really, really hard problem because I think there's a strong tendency within the field to overpromise. Particularly from folks who have, who maybe don't have the technical sophistication to even evaluate their own promises. So folks who want to promise a magical AI solution because they fundamentally don't know what AI is capable of. They're simply attempting to sell it. I think that creates a sort of contamination in the adoption market for real companies with real problems, looking for real AI solutions, wading through a bunch of garbage. Being pushed at them. And so I think that's a really challenging space. And a lot of like how I think about where I want to spend my time in deep AI problems these days is where I can prove out that there's something that's like really, really unsolved and you really, really want that uninvented, better version of the technology. And that just takes a lot of legwork. You end up having to ask for a lot of introductions, talk to a lot of people, really dig into understanding their work and getting outside of your comfort zone, not thinking in terms of someone who has VS Code and terminal open every day, all day. You just have to put yourself in a very different sort of shoes if you're going to try and solve problems that exist for non-software developers.
Completely. That's why I was like really fascinated when you told me you were in the working as a leader of some tech company and you're founding companies now, and that's a really amazing thing to hear. So moving forward to your other startup, so Intent Media. So does reliance on cloud providers like AWS centralize too much power in AI development?
Oh, okay. Well, so let's see. Should we talk about the cloud or should we talk about Intent Media? Those are two kind of separable topics.
Separable topics, right?
Yeah, so let's see. I'll talk a little about Intent Media and I'll steer it back to the
Sure,
cloud.
sure.
Okay. Briefly, Intent Media was a New York-based ad tech startup working primarily within the travel sector, really building machine learning systems for understanding user behavior for the purpose of creating a more competitive and profitable marketplace for promotions for travel advertisements. And so there's a lot of AI technology for understanding user behavior and pricing and promoting things in a very standard ad tech way, but with a sort of different marketplace angle on how to kind of think across a whole vertical like travel, where there are many players and there's many possibilities for reason why someone might transact. That company was built entirely on AWS. So a lot of the work that I did there was really focused on maturing the technology and making it possible to take better use of cloud resources. I will say at the time that I was doing that work, which is it's probably 11 years ago at this point, at least some of the earliest parts of it, it was just really, really hard to do ML that you knew how to do over a real-sized industrial data set. I would say, so, at the time I was doing this was sort of what we call the big data era, which I would say kind of has an early part and a second part. The early part is very Hadoop bound. Hadoop is a sort of open source re-implementation of MapReduce, and originally developed at Google. It's a family of JVM-based technologies, extremely heavyweight, extremely inefficient. And so for people who were ultimately developing what were machine learning iterative algorithms, these sorts of solutions that were being positioned were extremely expensive, clunky, and difficult to use. And cloud solutions, like at the time that I worked a lot with Amazon on their Elastic MapReduce product, which was a way of running Hadoop in the cloud dynamically. So we did this both at Intent Media and X.AI. Really, really helped simplify some of that pain of being able to build distributed computation for the purpose of actually building those higher level applications. I will say that the second chapter of this whole ecosystem really is about Spark and everything that came after it. So I spent a decent amount of time involved in Spark and its open source ecosystem. A lot of my first book is written in Spark code. It's all written in Scala. And I think it's really like something that folks who maybe started their careers later are unaware of. Is just how tremendously inefficient things used to be just for being able to write iterative algorithms like machine learning code that needs to update gradients and so forth and keep data in memory as opposed to on disk. Spark had a huge impact on the efficiency of those workloads. And so AWS is a great place to run Spark jobs, but so is Databricks, the creators of Spark, and so is everywhere else. And so I think we were in this position now where like a lot of these core capabilities for running distributed data processing for common workloads like machine learning, it's so portable that I'm not super worried about the power the clouds have. I think they're largely enabling because so much of what they solve are the things that are, to you, a commodity. So if you're, Intent Media's ad tech company, the valuable part about that is the data they have about this customer segment, the relationships to acquire that data, the ability to bridge it and understand the behaviors within these segments, enrich it with additional like domain-specific knowledge. All that modeling of the actual problem, that's the part that everyone in that company should be working in. And the challenge, I think, 10, 12 years ago was way too many of us were just trying to make the server stand up and not fall over and get the data onto the disk and then back off the disk, despite the fact that we're just doing this like really what should be a very simple iterative algorithm. Those days were really, really hard. And thankfully, like there were some cloud solutions which improved that, but now things are just a million times better in terms of developer productivity for developing distributed machine learning jobs. It's just a wildly different world.
Completely. So how do you design systems to handle both batch processing and real inference?
Yeah, I think this is something that I spent a lot of time like earlier on in my career kind of building heavily into the architecture, and I really kind of chunked it out separately when I wrote the machine learning systems book. And then as the field has gone on, I think it's become an interestingly blurry space these days. The difference between, let's call them generically training versus inference workloads. There's a couple of other alternatives like benchmarks, fine tunes, etc. I think the interesting thing these days is a lot of people don't need to be in training. Some people maybe need to be doing fine tuning, but fine tuning is a sort of special case that's much easier than training. And so the range of organizations that need to be doing training is very specific, and oftentimes like it can be really, really big bet. So I think the good news, bad news is that if you really like working on training as a problem, I think there's very specific sorts of organizations that should be doing it, and you should really steer towards working on them. The applications of machine learning inference are much wider, and that's because if you want to do object detection, the chances that your organization has a whole bunch of distinct object knowledge that say Google's base data set has in its object detection model is pretty low, and if it's domain specific, you probably just need to do a fine tune, something like that. And so like I tend to think of like most organizations these days are even like are really like inference organizations. And then there are people who are in true like AI R&D companies building like novel models. And I think in those cases, like there just is a strong divide between training and inference in the way that like we, paralleling our earlier discussion, many product AI foundational model companies are open weights. They give away their product for inference mode, but they would never give away their training scripts. They would never give away their training data, the ways in which they hyperparameter optimize, preference align, things like that. So I tend to think that they're pretty distinct topics these days, and that the good news is there's a whole new crop of cloud providers that are even more advanced and sophisticated in providing really excellent products suited for these use cases. The two that I put top of my list right now are Replicate and Fowl.ai. I would call them new school Gen AI clouds that know everything about like how Gen AI models are handled. They come with great model marketplaces of existing good models from open source in them, as well as commercial models. Their boot time is incredible. Their latency is great. Their cost control is really, really fine-grained. And so you have the ability to really arbitrarily compose Gen AI model calls into novel applications, treating them as opaque primitives that you don't have to modify. And I think that's a lot more of like what the vast majority of people need to be doing these days, is having an understanding of what a given model category does. But for so many applications, you're really using, even if you're with an AI product, you might be using 5 models and 4 of them are commodity. And you're really only like making changes to the 50, right? And so the ability to be able to put those things together, to plug them in, to see, there's a new Gemini release, let's check that out. Or like, that OpenAI thing isn't performing as well as I thought it was going to. I'm going to flip back and use this other thing. That incredible speed of recombinant innovation and focusing on the part that is distinct to your organization, that's how I think about like where your attention should be in some of this architectural stuff these days. And I think that's heavily inference bound. And then we'll see if how much of that ends up evolving into being fine-tuning related workflows. But even those I tend to think are most commercial applications of fine-tuning look to me like highly abstracted, meaning that like the user shouldn't think about themselves as fine-tuning. They should just be like, here are my products. Make sure that you recognize them as an opaque user intent that doesn't necessarily have to know about things like fine-tuning jobs and accuracy of fine-tune recognition and things like that.
So what's the most underrated challenge in building cloud ML infrastructure?
I don't know if this is the most underrated, but I will say this is. I think it's not everyone is aware of this one. So it's really, really hard to know how well a given model performs. Even an open source, widely deployed model that's been published, that has benchmarks that evaluate it in different papers, to really understand model performance, it's just incredibly hard. Some of this has to do with like, what do we measure against? And so I think there's this weird world where academia is doing great work and industry is doing really expensive and really good work. But the academic benchmarks that we use to communicate in the literature are oftentimes quite a bit abstracted, simpler, and frankly dirtier than customer requirements if you go out into the real world and try to solve a real commercial application. And so, and I would say this is true in a bunch of different domains, is that it's just really hard to know like how good are you really within your modeling techniques based on just the limitations. A university only had this much budget, only had this many students, and so they put up the best sort of paper they could on a benchmark, and then people wrote 50 papers evaluating against that benchmark. That doesn't mean that that's like the ground truth. That's just the best benchmark we have. And I think that really, really impedes the ability of people attempting to understand real-world behavior of models, particularly given how much money is flowing into Gen AI these days, that there's a strong dominance of the marketing language over a grounded technical understanding of what are the dimensions of performance that may matter for your application. And so it gets to be really, really dirty water to be able to perceive. For example, I think there was a lot of excitement around DeepSeek's R1 results, and so I've encountered folks who seem to think that, oh, is that the best model now? The best model in what terms? There were many equivalent models that do test time scaling and a reasoning sort of model. What domain are you in? Are you doing code gen? Are you working on natural language? Are you doing a RAG application where you've got a grounded context? As well as do you care about your infrastructure cost? What are your latency requirements? Are these batch jobs? Can you afford to wait? And so I think these sorts of challenges in reaching precise, technically clear conclusions about the performances of models across categories is just getting really, really hard due to a lot of these profit motives for people to market their products. It's still really hard, if you want to put just pure technologist hat on and say, okay, but what's actually the best model for my problem? What's the best method? If I wanted to make it 5% better, would I use a different model? Would I add more data? Would I fine tune? Can I afford to distill this? Can I quantize this for even lower latency? Those sorts of things are really, really hard to do with reliability, and they can get really expensive. If you want to be incredibly principled and test everything against everything, you start to build these multi-dimensional matrices of comparisons that are really hard for most organizations to work through in a reliable way. And so what you find is most people are just kind of actually buying the marketing language in a lot of contexts that could be more technically driven. And I think that represents something of a missed opportunity and probably a sort of local minima or something. I don't think that the end user for a lot of Gen AI applications wants products as low accuracy as a lot of what's going on in the field. I think we still have a bunch to invent. I think we have a big bar from where we're at in Gen AI to where we actually solve all the things we're pitching people on today, where we can in fact, fully automate human accomplishment of some routine administrative task using fully vision models to read and recognize what's on a computer screen and navigate out. All those tech demos are really, really fun, but the idea, when you talk about true real world task accomplishment on exactly the metrics that matter to you, I think that's just so hard to evaluate, given this sort of weird interplay of easy and dirty academic benchmarks and then puffy marketing language, and then secret internal data sets that are the real versions of figuring out how to do things right. It's so hard to know how to navigate these things, and to do that thing I propose we should be doing, which is compose up models as primitives in more sophisticated compound architectures. Don't worry about what's inside the black box, because someone else makes sure that it's there for you, that it runs fast. That's the developer high productivity way of working on these things. But I think it's definitely intertwined with understanding model performance in a reliable way.
That's amazing. So moving forward to your current work now, multimodal and image research. So why multimodal AI is exploding now, and what's the killer use case?
Sure. Similar to what we were just talking about there, I tend to think that there are a lot of things that are beyond the language domain, or at least not just about language, that people would really like to see AI addressing, being able to deploy agents to be able to have more fully autonomous AI workflows that aren't solved yet. And so a lot of these, I think about it in terms of what vision models are capable of, which are tremendously sophisticated capabilities these days. There's lots vision models can see in the world and reason about, and the ways in which vision models are fused with language models. So typically we refer to these models today as VLMs, vision language models. And so you can point to a camera at a scene and it can tell you that if I knock this over, fluid might come out. Things like that they work pretty well. but they're the sign of what we really want them to do, which is far more Turing complete and far more general in the ways that they do things. And so there's some areas where this gets really, really extremely far below what people want. In terms of some of those real world applications is every limitation of a robot versus what you imagine a robot can do when you see a movie. There's quite a lot of the robotics field has consistently been the sort of laggard in all of AI in terms of being the hardest test bed. But there's also like things like grounded image generation. So actually being able to generate images which conform to specific requirements constrained by reality. I would say image generation is so much further back than vision models, and people are confused because they see a shiny astronaut riding a unicorn, and so that they think that anything is possible. And I think anything is I think if you can see it in your head, you should be able to see it in a screen. That is not remotely the state of the art today. It is so trivially simple to demonstrate the edges of where current generation image generation technologies are, and see them break and see them not do even basic things that any photographer or digital illustrator could do. And so to me, I think this is the space of really can you raise the net closer to where real people do real work and test current gen AI against it, see gaps, and use that to motivate important research and development. Can you lean into the parts that the field knows it is not really good at? Whether that's something like image generation, where there's excitement around, I would say, consumer use cases and challenges in doing the enterprise real world use cases, or things that just seem like really, really rigorous and difficult domains, like robotics, like a lot of the applications in biotech. When you're up against a real world bar, then I think those are the things that can get to be really interesting, because if we can complete true sophisticated multimodal intelligence to be able to reason about commercially interesting concepts, you're on the way to having agents that can earn their own compute bill, and you're solidly into sci-fi territory. If something could accomplish freelancer tasks by looking at the screen and writing out text and editing images and sending them back to the client and blah blah blah, there's a lot of things that could be done there. I don't know if all of those things are I don't know where we're at on the progress bar, and I think there's a whole bunch of social implications to them. But I think it's very interesting science to lean into, to say, what are the tasks that are pretty easy for a human, still really hard for AI? What do they point to around the research tasks to do? What sort of intelligence capabilities should we be working on? And whether that's benchmarks, data sets, methodological experiments, validation environments, et cetera, et cetera. The work continues. Despite the buzz, we haven't solved AI. None of this is done. It's all just promising.
It's just the beginning, right? So,
yeah.
How do you address bias when fusing vision, language, or any kind of data, or even audio data?
Sure. I think bias is a really important topic. Responsible AI is really, really hard. A lot of it starts in the data. And I don't think that you can ever completely solve such things by only caring about the data at the input to the process. And so ultimately, I think about how do you develop discriminatory capabilities within your modeling infrastructure at several points in the life cycle to understand your performance across dimensions that are relevant. And so responsible AI researchers care about this, commonly in language and image domains. There's also some really relevant stuff within speech as well, like support for multilinguality and non-native accents and things like that. I think they're really important when we think about AI, actually touching everyone. AI is not an academic curiosity, just only existing in a few universities like it was a few generations back. It's a real-world technology touching every person on the planet. And so I tend to think that these are not just the concerns of anyone, of academia, industry, government, society. It's a tricky interaction of different stakeholders. speaking for myself as someone who builds technology and does things like, bring together the resources so that other people can produce technology. I tend to think that if you're starting with that assumption that AI is going to touch everywhere in the world, there's very few products you should build with like a very like provincial and local sort of perspective. And I think basic training really should begin in school around understanding the impact of the ways in which your data sets are constructed and how those impact the work that you do. I think the supervisory capacity when leading a team, doing some research tasks, I'll often talk about like what are we defining as within the space of concepts that we're modeling and the categories that we're evaluating, and how we create principled data sets through structured sampling from some base data set. I think this sort of like select star approach of the sort of take all the garbage on the internet and shove it into the model sort of thing, that time has passed. I think there's really no reason for it anymore, and so that and you can see it failing extremely in things like Gemini summaries that are contaminated with Reddit poison sentences that have profanity and threats of violence interpolated into a sentence as a result of Reddit data poison, which is just a ridiculous and completely unnecessary failure mode. I think there's just better ways to do this work, but it's a part of the field growing up, and I think there's always a motivation in at least the startup portion of the ecosystem to move fast and break things, to just scrape in all the data, don't do much cleaning, don't think about stratification and sampling strategies and how to work in principled ways with the data, and for that matter to measure against it until it's all on a lagging basis. But I think that's hopefully changing as a result of most AI being evaluated against what I would call like an enterprise software bar. Like, would a big company buy this? No, because it does really offensive and bad content comes out of your model. Oh, I see. Maybe that's not the one to buy. Maybe that's not the one to invest in. Maybe that's not the company to work at. I've definitely heard from people in the field these days who are experts in AI, who care about maybe the bad reputation of some team and what people use their model for and what comes out of it as being a reason to not work at a company these days. And so I've definitely seen this on the labor market perspective, and I hope I see that more on the investor side as well, because that really limits speed. That's really what drives behavior. If your bad model can't get funded, then you're going to care about responsibility. And so I think ultimately investors are always the point of leverage.
Right, yeah, that makes sense. So what's the most common blind spot you see in the AI first startups today?
I think there's a tendency towards extreme optimism. And I think that optimism is oftentimes pointed at the customer. It's trying to tell a story of a magical outcome that they hope to achieve. But it's not grounded in a deeply principled technical understanding of the performance properties of their task of concern. And so this may work for the early stages of fundraising. It may work for getting demos and pilot engagements. But I don't think it works for a lot of the real world potential applications of AI these days. I don't think it's you're going to get a lot of customers 5 years from now with the standard racially and gender biased image generation capabilities in your average flagship image generation model these days. I think they're to pick on a particular category of models that I think do poorly. And so I think that and I think the same is true as also people who promise quite utopian outcomes, like people who will sort of raise around before they've got the capability to perform their task of interest. I think there's a bunch of things going on in code generation right now where I think a lot of progress has been made, but it's very quickly to jump out to sci-fi fantasies of what sort of code generation are we currently capable of doing, what will we be capable of doing with more work, right? And so I think it's I think that sort of like realism and understanding your tasks deeply, starting with like an empathy for the ultimate task and the users that you're serving, I think is just the biggest thing out there. And then mapping that up to like a principle of like research and development methodology. I think this is what happens when things get buzzy and there's a boom on. Is that people want to hope for the best, and the reality is that scientific research, including computer science research like AI, it is bounded by these real deep constraints, and that the methodology of the scientific method is how you keep the net up. It's how you keep yourself honest and understand how you make progress. And I think it's just much harder than folks imagine, and I think that's a big determinant of what really develops breakthrough technologies. Understanding what's hard, what's realistic progress to make, and focusing in on the parts that are most tractable from a methodological perspective. I'm going to note that we are solidly over time, and so I think we're going to have to wrap up here.
Sure. So, what's your plan and vision for your future? And the common question: how can our audience can reach to you? Like, if they have any questions or anything that you can help them with. All right.
Sure. Yeah. So, right now I'm very much in a research mode. I'm involved with an accelerator, Savant. I'm involved with a couple of funds, just as an LP and advisor. Firsthand, BC, the main one, but I'm also helping the folks at Beacon Fund, it's Ryan Hoover. And I'm generally like thinking about what's next in this space and trying to research and build and try to find a way to do new things. I'm generally always happy to be helpful to folks who are working on early stage AI stuff where they're trying to build new things and get connected resources. Easiest way to find me is at jeffsmith.tech, jeffsmith.tech. That's got my contact info, and you can find me there.
All right. Thank you so much for joining our podcast today. It was really honor talking to you, and hopefully let's meet again and with a lot of new stories and maybe a lot of new companies of yours.
Yeah.
All right.
Yeah, thanks very much. I appreciate you inviting me on. Be well, sir.
Yeah,
bye.
Thank you.